So putting in my earplugs for the grinder. I don't have a guard on the grinder, and that is the way I use them most of the time. I actually find it safer, but I won't discuss worrying about that at this point, as I happen to do an industrial accident in the middle of this. Hopefully not. When this part that we have, it came in broken. We have another video that we worked on that is making one of these out of steel for the customer. I had also given them the option of making one not making one out of cast iron, but repairing the cast iron piece. A lot of people don't like repairing cast iron because they've had bad repairs. A lot of the weld situations that are done for cast iron are not really welding, as in using cast iron, which is the ideal way to repair it. But a lot of times they will use nickel or other things to put it together, and the interface between the nickel and the cast iron ends up with a hard steel where it has a brittle spot that ends up breaking. The most cost-effective way most of the time to repair a cast iron piece is to braze it. Now, we're not going to, what I had given the customer as an option if they were satisfied with still going with cast iron, was to go ahead and braze this part back together. And if we were to braze it for the customer, what we would have done is gone ahead and brazed up the hole also, and taken this surface down a little bit and floated brazing on top of all of this so that we could remachine the hole and the surface back to precisely where they belong. We're not going to do that today. Today what we will do is we will braze this together so that we have a good joint, and then we will test and see how good of a joint we have as far as strength goes. I want to compare breaking this off again after we braze it versus breaking off the one that hasn't been broken. So first off, we do have a nice fracture joint that still fits together to give us general alignment, but we need to get rid of some of this for a place for the brazing to go. So we're going to grind away some material on half of it for a place for the brazing to go into. Now as I've clearanced this out for some brazing to fit in there, it'll go into this V on this top side. A nice way to do this from the aspect of the heat of working with the part, because it's got to get pretty hot, would be if we'd have started on this side, but it wouldn't give us as nice of an alignment surface. By working with this being the part that we open up first, it gives us a better alignment surface. Now, since we're using this for our alignment surface, an easy way to fixture it is to just set it down on that plane. The problem with that, if we're setting on our steel table, is it's going to suck the heat away too much. That's why we got a piece of fire brick underneath us today. And when we braze this, it is going to pull up a little bit and get out of line, which, if we were worried again about being a perfect part, as it pulls up and gets out of line, we'd float more brass over that surface to make up for it, or we would slightly shim underneath this to give it a little out of caulk in the other direction. We're not going to worry about it today. Strong point of what we do at this shop is a lot of variety. That's also a weak point in the fact that our tools, things that we work with, are scattered all over the place. Because we're not just sitting in one place doing the same thing all the time. Now, the normal way you would do this, if you want to make flux-coated rod, which if it's not flux-coated, this is the old way, is you'd heat up the end of the brazing rod, and then you dip it in the flux, and a lot of flux sticks onto the rod. You also get a thicker coating of flux with it than what you will with the already coated rod. The already coated rod is handy, nice. It's not always what you end up with. It's nice to add sometimes a little bit of extra flux right on your part. And that way when you're first heating it up, it will have a little bit more of a... There's both a cleaning and keeping clean. Most of the information that you will see will talk about the brazing flux. We should stop for a second too. And brazing is a lot like soldering. And soldering is lower temperature, although sometimes they talk about hard soldering. Hard soldering is another name for brazing. The real difference between hard soldering and soft soldering is the temperature. And I don't remember exactly, but I think 1200 degrees is where they give a cutoff point between the two. There's a definite temperature as far as a real definition. One is the low temperature is considered soft, the high temperature is considered hard. And it's really not about whether the material is hard or not, it's just the temperature.
Temperature.
What's that?
What's the temperature difference between high and low?
Well, I think the cutoff is 1200. Low temperature can be down as low as 500 and some degrees, 400 maybe.
Okay.
That would be like your regular electrical solder, lead tin solder.
Yeah.
It's the alloy, what the alloy takes to melt. We're using brass today. They call it low fuming bronze, but essentially it's brass with a low quantity of zinc in it. It will fume off some, it will bubble some if you get it too hot. Originally, brazing was done with brass being copper and tin. That was the original, and then there were different alloys of bronze that was used for it. Sometimes bronze is still used in a brazing process, but most of the time it's a brass alloy.
Okay.
And the only real reason I can figure for that is cost. We're going to start out with I normally use the Victor tips, not because they're necessarily better, but because they're the most common in most places and definitely the most common where we live here in the interior of Alaska. I've had some Smith, some Harris, a bunch of other ones which were good units. But if you want to go downtown and buy something right away, the Victor is the one that's here. Put the grinder away, and yeah, I'll just leave it put away for a while. But I'll start out with a big tip. I've got some smaller tips lined up here that we can use when we start shaping this. The first thing you want to do is get your part hot enough so that the brass, so the brazing, I'll just call it brazing, so the brazing flows out on your part good. And if you don't get it flowing out good on your part, it won't ever stick. But as it gets hot, you don't have good control over placing your brazing where you want it with a large tip. And since I'm not grinding, I'll go to the face shield with some darkening. We can also preheat it with hard in a furnace with a bigger point. So the part itself is hot, but it's also a little bit of a problem as far as moving the part on the top. Especially since it's doing too heat. You can see that it's a red heat where it's at the point that it is brazing. Now what I'm going to do, and there's no sense in wasting the heat while it's still pretty warm, I'm going to go ahead and back grind out most of the material that we'll need to add in and a lot of what I just had brazed on there. You want to give me a C-clamp so I can secure that a little bit? Yeah, probably do it. Thank you. I don't want to clamp it too tight or I'll break my brick, and I want to leave it on the brick to keep the heat and also just not having to move everything aside. Clear shield so I can see a little more. I guess we don't have any real cameras, but then on the other hand, we don't really have to show grinding parts for our next camera. I don't think that's enough, but I don't want to go too far right away. sometimes I will make this part easier on myself by letting it cool off first. But we didn't today. It's okay. Right now you can see in there where there's a crack. And this is the original break right here, is crack. On this side you can see where there's a little bit of brass showing up. That's the brazing joint we just made. I want to get it so that I've got all brazing joint or iron and none of the crack left. Okay, now we have brass. We can see where we made a stringer of brass through here. There's a little bit of a crack line right there yet, but when I braze it, it will go in. I don't want to grind it away because I just don't want to take out that much more metal. There's little holes and things in a casting anyway, and we've got a width here in between the two. So it's not a matter of needing, if you see there's brass all the way through here, one complete strand. And that's part of ideally what you want too, is when you get done, you'd like to have your whole joint being brazing material and not leave the cast iron. Because the little bit of different expansion with the cast iron versus having all brass will cause it more likely to break again, just from moving from heat, especially if you're doing an exhaust manifold or something. Very important to not leave that portion that's iron in there where it can wedge against it. So we're going to go back to some heat. I'm not going to try and go all the way across all at once because I could easily melt it with this tip to where it will fall apart. And I may quickly swap to a smaller tip too. We'll see how this goes.
And sometimes I don't bother with this because the rod is relatively cheap compared to some of the studs, but this is one of those techniques that normally taught when you first do this. Go ahead and mount the rod onto the rod so you can keep going and not waste that torque.
We shouldn't need two on this piece, but just for effect, we'll go ahead and do a little trick that's normally used on larger pieces. Because larger pieces will have more problem with expansion and contraction as they cool off. And floor dry is just a very cheap high temperature insulator. And so that will help it to cool off slower. That ear being out there by itself, I don't think it'll matter much, but it won't hurt And as I say, it's just one of those techniques with brazing. You want to get it covered up. It doesn't need to be real deep. And like I say, since I'm not worried about it, I'm not going to worry about covering up the end. If I was, I'd put it on the floor, on the table here, and we'd put a couple 5-gallon buckets worth of floor dry on it. We can go in between. We can
6-inch
interpolate. We can interpolate in between 1, 2, 3, and 4 Bert feet. Kind of keep it from getting wild if it flings off. That was the breaking point. Okay. I don't know if we were pushed up that far. Let's make sure that our first bird inch is in the same. We were. Yeah, I guess we were up all the way. Okay.
All right.
Oh, we didn't put our wrench in there.
Nope.
Do we need it?
That might make it easier.
Which one did we have? Big one, little one?
Big one, I think.
Okay. Actually, the hole broke off before that, so we didn't really get it tested that well. This hole broke off easier than the other hole.
Wow.
But I think the brazing is fairly stout. I will do another thing. Don't move, don't force it, just get a bigger hammer.
Wow.
And as we see, for the most part, we broke the cast iron and not the braze. You can see that I failed here. I did not get a good braze. That was my not doing a perfect braze.
Oh, look at that.
And what that was I did not grind it out. I was getting tired of and didn't want to grind it out all the way. You can see where it had, where flux had just flowed in between the two at that same point. And it wasn't ground open. It really needed to be ground out further. I stopped grinding right here on that one. It really should have been ground deeper before doing the back braze.
Yeah.
But it still pulled the cast iron out of the other side before the braze broke. Tap from a small hammer. It appears that it breaks off relatively easy from a small hammer also. And actually, wrong part, that's why, yeah. Yep, we did have a little more contact area on the cast iron one, but yeah. Not really any stronger to speak of. Cast iron is a little bit weak. It has some advantages. The main advantage for it, why they originally made this piece out of cast iron instead of steel like we made our replacement, is because it's easier to machine. That's 90% or better the reason why they use cast iron. It's not a less expensive. Some people say, oh, it's made out of cheap cast iron. No. The cast iron casting will cost you just about the same as steel. The difference is when you go to machine it, cast iron, it's a dream to machine. It doesn't make a beautiful piece when you're done, but it is just easy to machine. It's got everything going for it. And someday when we're machining some, we'll show the difference.